Hello, this is Mr. Stein, and in this video we are going to go through examples 3 and 4 for section 6.1, the slope of a line. Once you're done these videos, you should be able to relate the slope of a line to a rate of change, quickly tell slopes that are positive, negative, 0, and undefined, determine the slope of a line from a graph and draw a line of a given slope, determine the slope of a line between 2 points using the formula. Alright, that's what we're going to do first. In example number 3, is we're going to use this formula right here. Slope is equal to y2 minus y1 over x2 minus x1. And I'm going to show you an easier way to, well, maybe not easier, a different way to write this out. So let's find example number 3. Determine the slope of a line that passes through the point E, 4, negative 5, and F, 8, 6. Alright, so I'm just going to give a quick sketch to see what's going on. Now E is at 4, negative 5, that's somewhere down here. This is point E. And F is at 8, 6, so 8, 6 will be somewhere up here. This will be F. Alright, so right there, there's going to be a rise, change in Y, and there's going to be a change in X. So from our sketch, it's looking like it's a positive slope. Now we're going to use the formula. Slope is equal to y2 minus y1 all over x2 minus x1. So I need to label one of these points 1 and point 2. So E, I'm going to call that one point 1. F, I'm going to call point 2. It doesn't matter which one is which. So this 4 is going to be x1, 5 is going to be y1. The 8 is going to be x2, the 6 is going to be y2. All right, let's fill in what we know. So it's 6 subtract negative 5. y2 minus y1. All over x2 minus x1. 8 subtract 4. It's important that negatives go into parentheses like this. So now our slope is equal to 11, 6 subtract minus 5 over 4. There's our slope. We can't reduce that. That is our slope. Now I'm going to show you a second way to do this. You take point 2 and put it on top. So, well, it doesn't matter which one goes on top. So F is at the place 8 and 6. This is going to be our run. This is going to be our rise. Then from that point, we subtract point E, which is 4, 5. So we subtract this. 6 subtract negative 5 is 11. And 8 subtract 4 is 4. So this 4 is our change in x. This 11 is our change in y. So our slope is equal to 11 over 4. We get the same result doing it this way. Okay, so you should be able to take 2 points, any 2 points, and use this formula here to determine the slope. Alternatively, you could do it this way right here. Gets you the same process. All right, let's take a look at example 4. Tom has a part-time job. He recorded the hours he worked and his pay for 3 different days. Tom plotted these data on a grid. What is the slope of the line through these points? What does the slope represent? All right, so let's take a look at Tom's rate of pay. So he worked 2 hours. He worked 2 hours, he earned $24. He worked 4 hours, he earned $48. He worked 6 hours, he earned $72. We could draw a nice line through this graph. Now, we could assume that if he works 0 hours, he'll get $0, but we don't know. Well, let's take a look at determining his slope, because that's the first one. What is the slope of the line through these points? So let's pull out 2 points on here. And let's look at the rise and the run. So the rise, the change in pay. So we start here at 24 and we go up to 48. So we get 24 plus 24 for our rise. Remember to use the scales on the axes. This is a rise of 24. And our run, our change in hours, is equal to, from 2 to 4, 2. So let's come over here and let's write out our answer to letter A. Our slope is equal to our change in pay, our rise, over our run, change in time. It's going to be equal to $24 every 2 hours, which is equal to $12 per 1 hour, or $12 per hour. B. Okay, this $12 per hour. What does the slope represent? The slope represents his pay. More specifically, his pay rate. That's given in dollars per hour. This is a rate of change. The rate of change is how fast his wallet changes in terms of money. So this is a rate of change. The rate of change is $12 for every 1 hour. Letter C. How can the answer in part B be used to determine how much Tom earned in 3.5 hours? Well, let's look at I. It's $12 per hour. Okay, so if he earns $12 in 1 hour, how many dollars is he going to earn in 3.5 hours? We can set this up as a proportion, similar to workplace math, and cross multiply. We do 12 times 3.5, and we should get 12 times 3 is 36. 36 plus another half of 12 is 6, is $42. So if he earns $12 in 1 hour, so if he earns $12 in 1 hour, that'll be the same thing as $42 in 3.5 hours. Just using basic proportions. Now, how long did it take for him to earn $30? Well, we can work this as a proportion the other way. In 1 hour, he earns $12. So in how many hours will it take for him to earn $30? Well, we do our cross multiplying. We take our 30, times it by 1, then divide it by 12. 30 times 1 is 30. 30 divided by 12 is just 30 over 12. So it takes 30 over 12 hours. Now, some of you might not like 30 over 12 as hours. That's going to be, what, 15 over 6? Sorry. I can divide them both by 6. Ha. That'd be nice. Divide them both by 6. I get 5 over 2 hours, which is 2.5 hours. So it takes him 2.5 hours to earn $30. All right, now we can make a formula for this as well. The amount that he gets paid is equal to $12 an hour times the hours he works plus 0. We don't need this plus 0 at the end, but it's just indicating where it crosses the y-intercept. So that would be a formula that relates his pay to his hours. So in this example, we looked at how the slope of the graph, the slope of this graph, related to a rate of change, a pay rate. All right, well, I hope you found this helpful. If you have any questions,